Welcome. Today we have a very special guest exploring the Ka inside the Eye of Ra. We're going to be broadcasting this on the Truth Frequency Radio Network and on my Quasar Network platform. We have the one and only Professor Chandra. And not only is he a world famous author, but astronomer. I think he even coined the term astrobiology. So it's really an honor for me to be able to spend some time with you once again and have a series of conversations.
Thank you. Thank you. It's always good to hear from you and to talk to you.
Yeah, thank you. Likewise, and like I said, it's you've been so influential in my life, and I could ask you a million questions.
Okay.
So today I really wanted to focus on the interstellar objects.
Okay.
Yeah, and for people that might not even be aware out there is that we've had a big upstir between Oumuamua and then Borisov, and this has been a lot of talk. So first, can you actually explain what an interstellar interloper is for everybody out there, and also if the differences between maybe we can get into with Oumuamua and Borisov.
Okay. Oh, there's not a lot of difference in terms of their orbits. I think they're pretty similar in that they both came from very far away places in interstellar space, right? We know that comets approach the inner solar system on a regular basis. We know that there's a cloud of comets called the Oort cloud of comets. About 100 billion of these comets in a shell around solar system. That's the main reservoir of comets in immediate vicinity. And we think the icy planets, Uranus and Neptune, were made essentially from a agglomeration of cometary material. That's what it looks like when you look at the composition of these planets. Anyway, so that's the sort of home reservoir of comets. And from time to time, when a star passes very close to, or when the solar system passes very close to a star, you have comets being perturbed from the Oort cloud into the inner solar system, right? They get pushed in, as it were. And some comets that go close enough to Jupiter are rounded up by planet Jupiter. So there's a Jupiter family of comets. And these are relatively short period comets. They're all homegrown comets, as it were. They come from within the solar system. So these are the most frequent comets that we see in the sky. We also know that these short period comets, as they go around the sun, and some of them go not so far from the Earth, they leave a trail of debris, of dust and molecules and so on, and even bigger pieces. And these are the so-called meteor streams. We identify the various meteor streams with the orbit of some parent comet. So that these are all sort of the home situation for comets. For a while, for about maybe 50 years, astronomers have argued that there has to be something like a comet, one comet every year that comes from much further out than our own solar system, than our own planetary system. But they have been very difficult to detect. The first definite detection of a comet that is supposedly, we know is a extra solar system comet, was, as you said, Comet Oumuamua in 2017. And that was a great bonus because we had orbits. We could calculate the orbit of the comet. We could calculate how close it got to the sun. And in fact, everything about the comet could be calculated. We also had the capacity to observe the comet using telescopes and instruments on satellites. And some very interesting discoveries were made that are still rather baffling. For example, it was found that the comet's emission from the comet was variable. It was almost as though we had something that was toppling, a long object that was toppling. That was one of the most sensible ways of explaining how there was light variation of reflected light from this comet.
The way it was rotating.
It was rotating and presenting different aspects, the narrow face once and the long face and so on. So this was observed, these measurements are made. And there were other measurements made, for instance, that the reflectivity of the surface, the albedo of the surface, was reckoned to be very, very low.
Wow.
Okay. And so the question is, why is that the case?
Yeah.
And there've been many, many speculations that have been made to try to come to grips with that, right? Well, one of the startling claims that were made by my friend Avi Loeb was that this is an artificial sort of residue of a shell of some kind of spacecraft that was going into the inner solar system. I personally, after a lot of thought about it, I would like to have.
I think people want to believe it. Yeah.
I would have liked to believe it, but my colleagues and I, about a year and a half ago, we made a thorough analysis of all the data, and we reckon it's much more likely to be a very dark comet, dark in the sense that it's very low reflectivity, almost surely a carbonaceous surface, and one that was toppling. And this was also consistent with the fact that there's no tail. And one of the arguments for the sort of spacecraft is that comets usually have stuff coming out of it and defining a tail, and there was no such tail observed for.
Well, that's interesting, because what makes certain objects sort of go right by the sun, and then other objects sort of gather to it like a moth to a street lamp?
Yeah.
You know.
Yeah.
What's the like? What is that? Because maybe one object came from another Oort cloud. From
yeah, I think that, I mean, as I will tell you, I think something like one or two of these extra Oort clouds or extra solar comets come into the Earth's vicinity every year, and so you could, in some way, like what you suggested, distinguish between those and the homegrown comets. But as far as Oumuamua is concerned, I think it is a comet that is very similar to, for instance, Comet Halley, or the comet that was examined by the Rosetta mission, Comet 67P PCG. They're very similar in the sense that, as far as we can say, they're very dark objects, very low reflectivity, and they must, I think, be made of organic material at the surface that has got, essentially coalified or charred, right? And that's what we see as this black, long, porous comet. And porous also because have I lost you?
No, I can hear you. You froze for a second. Can you hear me? Can you hear me?
Yeah, now I can hear you.
Yeah, you froze for a second. Yeah, you froze for a second.
I don't know what happened.
It says the internet connection was unstable for a second. It must be the connection.
Yeah. Anyway, so that's Boris. I think that's a comment to Oumuamua. I think it is a natural object. I think it is a very porous surface, and we have modeled it as though it was really like an aerogel, a dark carbonaceous aerogel, and all the astronomical data, the observations are consistent with that. So we don't need to invoke a intelligent first cause for it.
Yeah.
Now, come to the second comet, which was a bonus for us. 2 years on, we have Comet Borisov, which is also hyperbolic orbit. It comes from deep space, right? And that is different because Oumuamua does not have a tail, as I pointed out, does not have a tail, does not have a coma of gas around it. Now, Comet Borisov has such a tail and such a coma, and so it is behaving more and more like a normal comet, like a normal homegrown comet. So there was a difference there, and I think it's not a matter of great significance. As far as I am concerned, they both came from space, and they are both almost certainly carbonaceous. They are almost certainly, and this is the point that is controversial, but I firmly believe they are also the carriers and the transporters and the transferers of living particles, bacteria and viruses,
Yeah,
from one solar system to another.
that's what I believe as well.
So that sort of summarizes my position. The theory that it is an extraterrestrial craft for Oumuamua is exciting, but I think there's not a lot of evidence to support that.
Yeah, is it? I agree with you. Is it possible? But it doesn't mean that it's not part of the divine intelligence of the universe and God. Maybe there's a reason for all of it. It's all sort of, there's a reason for it all. Maybe there's, even with like, and is it impossible, like when something like goes from white dwarf to a supernova and there's these gamma ray bursts of energy, is it possible for rocks and different things and debris to get ejected and to throughout the universe that way from that explosion?
Well, an explosion would throw out material, but I think the comets like the interstellar comets like Oumuamua and Borisov are just comets that have escaped from a neighboring solar system. We know that in our solar system, from our Oort cloud, of the order of 1 to 10 comets do leave, right? Do leave our solar system, our Oort cloud. So those become interstellar comets. So there is a genuine population of interstellar comets. There is also the observations that were made following the Kepler telescope observations from started 2009. We know that there are extrasolar planetary systems, right? Planetary systems that are more or less carbon copies of our planetary system out there in the Milky Way. And the number of these systems is really quite large, huge. We didn't realize until some couple of astronomers have made estimates now that there are probably something like 140 billion exoplanetary systems in the Milky Way alone.
Wow.
Say 100 billion as a round figure, but that's a huge number.
It's amazing.
And we haven't, there's some sort of vague indications that some of the nearest ones might have exocomets, but that is still very difficult to prove beyond doubt. But I think by the normal rules of sort of what we have here, what they must have their sort of rule, the other solar systems must have formed in the same way as ours from gas clouds and comets and so on, and cometary clouds must also be around them. And the only instance where we see such a hint of an event process is that, I think, I can't remember the name of this exoplanetary system, but there is one system where the light fluctuates, indicating that there is some screen of material that is sort of transiently blocking the light from the central star, like an Oort cloud.
Yeah.
Anyway, that's as far as we can say from hard evidence.
Yeah. Well, that was another interesting question that I was wondering. Is it possible for Oort clouds to exchange objects with each other?
Oh, most certainly.
So what's the conditions? Do they have to be at like the right speeds and everything?
At the right speeds. I mean, if Oumuamua came at the speed that it would be captured by the solar system, it will be captured by the solar system, by our solar system. There would be relatively rare events, but there would be intermingling for sure between neighboring cometary systems. So again, we cannot regard ourselves as being completely isolated, even in regard to comets. We like to think that we are special, we are protected from everything and so on. That's not true at all. We are exposed to all of the bits and pieces that are flying around, and some of them can hit us, Some of them can be captured by our sun, and so on.
So the comets, theoretically, I mean, of course, we're saying because we don't technically, I guess, have hard proof, but theoretically, one comet from another Oort cloud could be carrying bacteria with DNA in it and bring it to our Oort cloud, and right?
Absolutely. And the comet itself can sometimes be captured, as we talked, as you said, but they don't even need to be captured. Now, when Oumuamua came, if it had a tail, it didn't have a tail, but if it was throwing out debris,
Yeah,
that debris could be intercepted by the Earth, and the debris is more than likely, according to my thinking over many years, it is almost certain that this would be a high chance of carrying DNA and living entities, and then we could mop them up. So, I mean, to think that the Earth is protected biologically from the rest of the universe is absolutely crazy, I think.
Yeah, I think that would be my, of course, people want to say about the Big Bang and even Darwinism. I would say that you guys were all, you and Fred Hoyle, the late Sir Fred Hoyle, were right all along that the evolution and is coming from space, right?
Oh yeah, no question about it. I think we have had this argument, this theory, Ra, now for what, from nearly 40 years, right?
Evolution,
Yeah,
space, right? We
say
got
that.
even cosmic dragons,
Yeah, all that.
cosmic life force, life cloud, even cosmic womb. Robert Bouval, for a researcher, that must have been a dream to be able to do a book with you.
He really enjoyed it. We met
Yeah.
several times. I don't know whether he's all that well at the moment. I haven't seen him for a while. He's been in hiding, but yeah, it was great working with him, and he has some nice ideas. Some of them crazy, but
Yeah,
are sometimes interesting.
that's how we figure things out, right? You got to have theories. So also too, do you think it's possible, or is there any like promising evidence to support the existence of Dyson spheres anywhere throughout the universe? Because I know there was this controversy about the Tabbys Star. Have you ever heard of Tabbys Star?
Yeah, I know a little bit about it. I think what the Tabbys Star did was the argument was that this was an exoplanetary system, right? Wasn't it? I think it was an exoplanetary.
I think that the light was, the light, they were noticing the light was dimming out in certain parts.
Dimming out and being blocked, and
Yeah.
almost as though a screen was revolving around it, doesn't it?
Yeah.
A screen of Dyson sphere.
I guess they were wondering if something was harvesting that energy or doing something to block it out.
Yeah. Well, that is, I mean, logically, that there is a possibility that this could have been the case, that they could, if you think of a screen with regular holes, right, orbiting the whole of that exoplanetary system, right, like a grill, like what kind of a thing, like a grid with regular sort of holes spaced. But then you would expect this dimming to be very regular, right? It would be regular.
Yeah.
There would be a regular pattern to it. And I think what was found, and I'm still sort of saying this from memory of a couple of years ago, I think what they find was that it is fairly erratic. The ups and downs in the light curve is erratic and more consistent with just dust clouds.
I think it was in Cygnus.
Yeah, Cygnus. Dust clouds swirling around the star. If you imagine dust clouds, very irregular shaped dust clouds, is sort of rotating around the whole star system, then you would get that. So I think it's certainly not. There's no convincing proof from that star, from that system. The question of whether the whole process is convincing, I think Freeman Dyson is a very brilliant physicist and an imaginary person. And so he made this as a wild speculation, right?
For those that don't know, it's technically like a megastructure that's built around the sun or some. I guess you could you even do it around a black hole if you could?
You could, I suppose, but wow. think of a sun or a star like ourselves, our own solar system. That would be interesting to speculate. Maybe 300 years from now, we would have exhausted all our sources of energy on the Earth. The coal or everything is gone. And then, but we have enough intelligence, enough technology, engineering capacity to construct mirrors, hundreds or millions of mirrors, and swing them into an orbit, into sort of a spherical system around the whole star. And so we are essentially pulling together all the resources and focusing this energy on our home planet.
Almost like a big torus sphere or something, right?
Absolutely, yeah, something like that. So that was the sort of imaginative logic of that process. Now, whether that would be the outcome of intelligence developing beyond our level of intelligence and seeking survival, I am very doubtful. However, I do not doubt for a moment that there would be higher levels of intelligence that would be reached given time. If you're wise enough to survive as a species, if you don't blow ourselves up in nuclear weapons, warfare, it's a very good future that we can look forward to. We've lost again.
I can hear you. Really? I can hear you. You froze up. Yeah, you did freeze up for a second.
I think we're broken again. We have lost contact again. Right? What's happening there?
Yep. There must be some sort of unstable connection. Hopefully everything was all right with the recording, but
I don't know. I don't know where we lost our train of thought.
Yeah, we were just talking about the Dyson spheres. I mean, ultimately, do you think that would be like something to that, sort of similar technology would be ultimately the best bet for a civilization or a planet to survive and harvest energy?
I think sooner or later we are going to run out of energy. The sun is going to get dim, and more than that, I think we are going to run out of energy sources that are intrinsic to the Earth, like coal and perhaps nuclear energy would go on for a little while longer. Have you stopped again?
Yeah, I can hear you. You with me?
Okay. Yeah.
Yeah.
Is the recording?
Yeah.
Is it good now?
Yeah. Guys, if you're in the other room on the internet, just get off the internet. All right. Made sure.
Let me check whether our internet is strong. I think it is strong at this end.
Yeah, I think it's on my end because it said it was unstable for a second for some reason. But
at your end?
Yeah, it said it was unstable on my end. Yeah.
Okay, I think it's pretty strong at this end. So I don't know.
We should be all right now. We should be all right now. Yeah, so that I guess that's it with what we were talking about with the Dyson spheres. The other thing that I wanted to ask you about also is related to what we were talking about, is to bacterias. Do you think ultimately, like, instead of using radio telescopes to be sending, looking for extraterrestrial life, that maybe we should be looking to see where bacteria is coming from in space, who's sending it, and
I think that is the only way that we can think of in realistic terms, in terms for transmitting information across the universe. I mean, genetic information is already being naturally transferred. That's the way that we have evolution on the Earth. I think if the first bacterium arrived on the Earth, we know for sure something like 4.2 billion years ago. And then bacteria and viruses have continued to come with comet impacts. Some of them were disastrous impacts, caused craters and so on. But most often they were gentle incursions of cometary dust that carried viruses and bacteria. And if that continued to happen without any pattern, without any evolution, we would be stuck with bacteria. I don't believe that Darwinian evolution would have done anything at all except through the accumulation of genetic information, new genetic information.
You with me? Oh, come on. Professor? You there? Oh, this freaking internet. Hopefully he'll come back in. I think I lost him for a moment. We're with the one and only Professor Chandra. He's back. We got him back. You got to unmute, Professor. For those out there, we're here with Dr. Professor Chandra Wickramasinghe. We just had a few technical difficulties, but he's back online. Just got to unmute. If you can hear me, Professor, you just got to unmute your mic. Can you hear me? Can't hear you if you're talking. It says your mic is muted, so if you can hear me, just unmute the mic. There you go. You're back. Just unmute. Yep.
Oh, okay.
There you go.
Yeah. Yeah, I don't know what's going on.
Yeah, I think it was the internet. It was recording the whole time, but so we're back. So we have a couple more minutes if you can.
Okay. Let me tell you about the viruses, bacteria and viruses as conveyors of information, maybe also conveyors for transferring information that might be appropriate for SETI.
Please.
For us.
Yeah,
SETI.
because I figured the radio telescopes would be it's bizarre that they would think of using that always.
Absolutely. I think what is now clear beyond a shadow of doubt is that bacteria carry, and all living entities carry, what is regarded as silent DNA, right? In a bacterium, there is maybe 80% of the DNA of the bacterium allows it to survive, to live, and so on, and replicate. But there is a small fraction of the DNA of a bacterium that is bizarrely silent. It does nothing, right? And recently people have tried to understand what that is due to. We don't really know, but I think if an intelligent civilization, biotech civilization, like what we might have on Earth, say 10 years, 20 years from now, that civilization would have every ability, technical ability to grow microorganisms, right? Insert messages, coded messages in the DNA, and just fling them out into space and create large numbers of these, trillions and trillions of these bacteria, and throw them out into space. And that would be the much more sensible way of transporting coded information, coded digital information across the whole universe, across the whole galaxy. We know that as a natural process, I think this is a theory that you pointed out to our book, Evolution from Space, which goes back nearly 40 years. But we've come a long way from that, Ra. We've found information after 2000, the year 2000, when the entire human genome was sequenced, unraveled. we discovered that there were silent stretches, mysterious stretches of DNA that were right through our own genetic sequence, right? DNA sequences.
Is it true that we have a cemetery of viruses in our?
We've got a huge amount of viral DNA in our genomes, right? And these are essentially relics of past pandemics, like the COVID pandemic that we have suffering now.
Wow.
There have been ancestors from our monkey ancestors, from our primate ancestors. They have been going through pandemics regularly, and each pandemic was a close call to total extinction. The line became extinct. But a small surviving fraction becomes essentially immune to the virus, and in those surviving individuals, there is this little information that is locked in, which is the virus information that they have undergone a certain viral pandemic. So that we have this right through, and every branching point in the tree of life from sort of our primate ancestors to humans, we can actually see these little bits inserted. So there's no doubt now that the whole of evolution that led even from primate to human was controlled by information, bits of information that came through pandemic viruses. So the pandemics do a lot of bad things to us and to our ancestors, but they also have the effect of possibly evolving us.
Wow.
So that's I think that's we got to grasp that and accept that this is a serious possibility, because otherwise there's no way of understanding the data that is coming from all this gene sequencing. But in terms of SETI, the interest here is that we can use the genome of a bacterium, right, and insert coded information to it. Coded information, and then make trillions and trillions of copies of these bacteria and just fling them out of the earth and allow the pressure of sunlight to transport these to wherever they will.
And these would be like bacterial phages with
with all the messages that we want to transmit, and they're not messages that are connected with their biology of the cells, but
even in one of your books, I think it was with Fred Hoyle with Cosmic Life Force, or one of the other ones, you guys talked about the icosahedron. The bacteria. It's interesting that's carrying DNA in it. And I was thinking that even in ancient Egypt, they might even be talking about sending bacteria. I mean, they talk about the solar barge and how and maybe the sun acts like a barge for the bacteria, and then the Great Pyramid is actually built in icosahedral fashion.
I think we tend to devalue the intelligence of all our ancient civilizations and ancient cultures. All these guys, even my colleague Robert Temple, who's an Egyptologist, showed me.
Yes, those books, Oracles of the Dead, Serious Mystery. I have them all. Yeah, I've read Crystals. Even the crystal sun, I have somewhere around here. The crystal.
Yeah. Oh, he's a great guy. I mean, some of his stuff is imaginative and science fiction like. But he pointed out to me, he showed me a reference from a Chinese papyrus, right? A document that is available for inspection now, where there is a definite statement of panspermia.
Wow.
Definite statement of panspermia and it's in a sort of cartoon sense, but
talks about like a solar sail or something like that.
Yeah.
Wow.
So this is, I think they knew it. The ancient Indians knew it. Like the Indians have connected panspermia with their culture, and so did the Chinese. So I think it's only the European civilization that has essentially rejected these ideas as being alien, as being unchristian, maybe. And
that's a shame.
Unfortunately, there are these sociological imperial aspirations. When the Roman Empire took over the Western world, they essentially removed all the things that they didn't like, for instance, the stuff of panspermia that was in Greek literature. Anaxagoras is a Greek pre-Socratic philosopher who wrote quite succinctly about panspermia. And this was overruled by philosopher Aristotle. Aristotle said that life didn't come from the universe. It starts in situ on the earth. So spontaneous generation started with Aristotle. So the older idea was then rejected. Aristotelian spontaneous generation took over, and it has continued. That dogma, that idea of spontaneous generation of life on a planet like the Earth, has continued from the early Christendom right to 2021. It is amazing. All the evidence that we have accumulated in 40 years and evidence in other directions also show that this is totally wrong. There's no way in which that could be the right answer. And experiments that are being carried out for nearly, 50 years in the most sophisticated high-tech bio laboratories in the world have failed to show that spontaneous generation can do anything.
Yeah.
But we still regard that as being a proven fact, and that Darwinian evolution following from that explains everything. So I think we are stuck with cultural imperialism, with all kinds of.
Should never be dogmatic beliefs in science.
There should never be.
It's ridiculous.
But it doesn't work like that. I think establishments, big establishments in science, like NASA and so on, they begin to have established positions. And talking about NASA, maybe we should really refer to Gil Levin, my friend Gil Levin, who died only about 2 weeks ago at the age of 96. It was quite a...
Oh, wow. I'm sorry.
He lived a long life, and he had, right to the end, he was quite a powerful character in terms of...
I have my Tibetan bowl. I'm going to hit it for your friend.
Okay. Well, so what happened is that I've written a couple of obituaries about him, but the story of Gil Levin is in 1976. There was the first ever life detection experiment taken to an alien planet, and that was to Mars, right? So the two spacecraft that were landed on the surface of Mars, and Gil Levin and his teammate Patricia Straat had an experiment to pour nutrient onto the surface of the soil, right? A nutrient that would be taken up by bacteria, and sort of monitor what was happening, whether there was carbon dioxide evidence of metabolism, right? So he pours this, he takes a scoop of the soil, pours nutrient onto it, radioactive labeled nutrient, and lo and behold, the whole thing froths with gas, with carbon dioxide. Oh. So total plus positive for the life detection experiment. He and Straat were about to make this announcement through the normal channels of NASA, and they were told to hold back until they know the result of another experiment, which was also being done. And that experiment on the same spacecraft was to look for evidence of organic material, organic molecules in the soil. But the instrument was not sensitive enough at that time to pick up anything. So
it turned up the sensitivity.
Yeah, it was because there was null. And so they said that no, this cannot be life. The frothing of his experiment could be life. It must be something else. And but a few years later, they sent other spacecraft to Mars, and they found lots of organics, right? But they didn't ever send another life detection experiment. This is a real scandal. And then I think there was also the evidence from methane. There was a European spacecraft that went to Mars and found there was methane in the atmosphere being produced. This was about 15 years ago. So the methane then had to be explained, and they said, oh, well, methane can come from volcanoes. It has to be volcanic. So that was sort of brushed aside. And then more recently, a few years ago, they found that methane was seeping out from the surface of Mars and seeping out seasonally. Can you imagine? In the summer, there's
Wow.
methane, and in the winter, it dries up. So again, no, there must be explanations for this. Maybe there's a sunlight heating effect of the volcanic. And most recently, they found a diurnal variation. Every day, there's a up and down in the methane. So it just goes on and on and on and on. I mean, evidence, harder the evidence for life in space, life on external planets.
It is possible, right? That like the life that's on Earth now could have started on Mars first, right?
I think the same life started on both.
Yeah.
I think Mars could have had life that was essentially diminished by some cataclysmic effect, process of some kind.
Could Venus has been a water world at one time? I heard.
Well, there is some speculation, but I don't think so. I think Mars could have been a habitable. It is habitable still for microorganisms, I think, below the surface. There is life, surely, microbial life beneath the surface, as Gill has had shown in 1976.
Is it possible that Venus could have been a comet at one time? Is that possible for something like that to happen, where something was at once a huge mega comet and then now it's a planet somewhere?
I rather think not, but yeah, I think it is too big to be a comet. It's far too big, and so no, I think it's a planetary object, and it's accumulated a lot of comets. A lot of comets have gone into its making.
Yeah.
But just as a lot of comets went into the making of the Earth, all the Earth's oceans, I think, came from comets.
Wow. It's interesting too that like with Earth, it seems life started as soon as the meteor showers and bombardments were done. Like as soon as so it's almost like the meteors came and that's what contributed to life starting.
Well, that's the recent 3 years ago, the results that came from studies of a rock sample in Australia, right, shows that the rocks that were formed at something like 4.2 billion years ago has evidence of microbial fossils.
Wow.
Inside crystals of zirconium. It's a precious metal, precious gemstone. And inside that, you can see evidence of fossilized bacteria. So there's no question that life arrived with these, and this is a time, 4.2 billion years ago, the Earth was still being formed in its last stages of formation, right? The surface was pounded with comet asteroid impacts. And so it seems to be that the comets that were impacting also brought the first life to the Earth. That process, of course, didn't stop because comets have continued after the Earth cooled, after the Earth's oceans were brought also by comets rather than any other process, predominantly by comets, because comets have a lot of water. Life continued to arrive in the form of microorganisms, bacteria and viruses. And it is the coming together of these components from space that essentially led to you and me and all the plants and animals and so on in a progressive, systematic way, with natural selection playing a fairly minor role. I mean, natural selection plays a role that in that if there's a creature that is not adapted to the particular environment, it perishes and so on. So there was a filter there, but the basic genetic components, I think, mostly came from space. That seems to me that, that was in our Evolution from Space book, which is 1980, and I don't take anything back from that. I think
which, by the way, both of you guys should have got Nobel Prizes for that, you know.
Well, I don't know. I think those are highly corrupted now. I hate to say that in your program, but No,
I agree, but I mean, I think it was taken away from you just because you went against the grain, you know.
I think so. And I think most importantly, Fred Hoyle should have been given the Nobel Prize for Physics, along with Willy Fowler and Chandrasekhar, for discovering the origin of the chemical elements in stars. And there's not a shadow of doubt that the first ever suggestion of that came from Fred Hoyle.
And some people assume that he was awarded the Nobel Prize. I've read in people's book, a Nobel Prize winner, Sir Fred Hoyle. I'm like, wait a minute. I don't think they gave it to him.
No, they didn't give it to him. It was too dangerous.
In the book, there's a book, Comets of God, where the guy talks about how a lot of the comets is related to the book of Revelations and stuff. And he said, and he quotes, he said, Nobel Prize winner, the late Sir Fred Hoyle. And I was like, wait a second. Did he really? And I researched it. I was like, oh, it's wrong.
He was denied, and that was a really, and his closest friend. I mean, the story there is that he linked up. He had this idea that the chemical elements were all generated through nuclear processes in stars, right? From hydrogen to helium to all the metals that make up you and me and the rest of the world. So he had this idea. He wrote papers about this in the Royal Astronomical Journal. And then he wanted an experiment to prove that this is so, because he predicted that if that whole process is going to work, there should be some very specific energy state in the carbon nucleus. So he needed a nuclear physicist to probe this nucleus of the carbon atom. And Willy Fowler was his friend, or his friend all along, in fact, at Caltech. So he went to Caltech several times, and Willy Fowler was eventually persuaded to do the experiment. And he found what was now described as a Hoyle state, a state of the nucleus carbon that permitted further evolution. So there's no question about it. This is on record, and the system is so bizarrely corrupt that he wasn't given the Nobel Prize along with all the others.
It's a shame. Man, you know what? Whatever, screw him. You know, it's at least people knew that. I think the majority of people realized the significance of a lot of what you guys did. You know, but mainstream, you know what? That's how it is. The people that are groundbreaking go against the grain. It doesn't matter if it's truth. Sometimes, you know, there's no funding in truth.
No, there's no funding. This is I think that societal constraints on the progress of science they're very, very powerful now.
And that goes even with cancer research and different things like
Absolutely.
that.
Yeah. Absolutely, yeah. And COVID research maybe.
Yeah.
As well.
Oh, forget it. Don't get me started.
I think just towards the end of your session, I want to say something that, I mean, Fred Hoyle left a lot of unpublished material in an archive in St. John's College, Cambridge, right?
Wow.
Unpublished essays. And one of his last unpublished essays, he sort of does a reassessment of his own scientific career. And he ends by saying that the work on the origins of life and panspermia that he did with me would be the most important of all his entire corpus of work. He's made that statement.
I would agree. It's amazing. It truly is. It really is amazing. And I want to thank you for everything that you've always contributed throughout all the years and continue to contribute. I will always promote your work, and if we can continue our series of discussions as long as we could, I would love to.
Okay, with pleasure.
Thank you for joining me today.
Thank you.
I wish you all the health, you and your family. And
thank you.
Looking forward to talking again. Take care. Let me stop the video.
Thank you very much.